Hello and welcome to GRE Quant channel. In this video, we are going to be discussing on the topic of divisibility and remainders. We will go through divisibility and remainder rules that are very important for your exam as you will be tested on the same rules. Now let us start with today's tutorial. In the expression 6 divided by 2 is equal to 3, 6 is the dividend, 2 the divisor and 3 is the quotient. Kindly note that 2 is a factor of 6 and 6 is a multiple of 2. This can further be explained by the divisibility rule, which says that if x is divisible by y, then y is a factor of x. For example, if 14 is divisible by 7, then 14 is a multiple of 7. Similarly, if x is divisible by y, then y is a factor of x. This implies the divisor is equal to factor, as we have already discussed it before. Now, every integer n will have 1 and n as positive divisors. This includes the prime numbers as well, because prime number will have that number and 1 as positive divisors. So, every integer will have at least 2 positive divisors. Now, positive divisors of 12 are 1, 2, 3, 4, 6 and 12. An example of multiples of 10 is minus 40, minus 30, minus 20, minus 10, 0, 10, 20, 30 and so on. Kindly note the GRE questions typically focus on positive integers. If x and y are integers, then x is divisible by y when x is divided by y and the remainder is 0. For example, if x is equal to 20 and it is divided by y, which is 5, the remainder will be 0. Similarly, 5 will be a factor and divisor of 20, and 20 equals 5k for some integer k, that is 4. 20 is a multiple of 5 and 5 is hiding in the prime factorization of 20. Are you getting me? If you do not understand it, can you go through this slide once again so that you can understand this rule very well. This table is very important for you to memorize. It is a trick to know whether a number is divisible by 2, 3, 4, 5, 6, 9 or 10. Kindly note that the divisibility rules for 7 and 8 are not needed for GRE. Let us begin with the number 2. Let's suppose that there is a number and we want to check whether it is divisible by 2 or not. We should just see its units digit. That is, we should just check if the number ends with 0, 2, 4, 6 or 8. In case of 3, we should see if the sum of the digits of a number are divisible by 3 or not. For example, if we add the digits of 36, that is 3 plus 6, we get 9, which is divisible by 3. In case of 4, the units and tens digits should be divisible by 4. And remember, this includes numbers ending with 00 as well. For 5, a number's units digit should be 0 or 5. I repeat, for 5, a number's units digit should be 0 or 5. That is, it should end with 0 or 5. In case of 6, the number should be divisible by both 2 and 3. This means that the divisibility rule of 2 and 3 apply here. In case of 9, the sum of the digits should be divisible by 9, just like 3. Now let us suppose that if we want to see if 279 is divisible by 9 or not, we will add its digits. That is 2 plus 7 plus 9, which gives us 18. And 18 is divisible by 9. to see whether a number is divisible by 10 or not, we should check if the number ends with 0, or in other words, a few examples of divisibility that we have already discussed in the last slide are given here. I hope you'll understand it well through this table. According to divisor rules, if we have j, k, m and n as integers, and if k is a divisor of n, then k is definitely a divisor of m into n. For example, if k is equal to 3 and n is equal to 21, then n into 21 divided by 3 gives us an integer, because 3 is a divisor of 21, or 21 is a multiple of 3. If jk is a divisor of n, then j is also a divisor of n and nk. For example, if j is equal to 2, k is equal to 7 and n is equal to 28, then 28 divided by jk, that is 7 into 2, will give us an integer. Similarly, if we divide 28 by 2 or 28 by 7, this is also going to give us an integer value. Now, if j is not a divisor of n, then jk will definitely be not a divisor of n. For example, if j is equal to 3, k is equal to 2, and n is equal to 22, then 22 divided by 3 into 2, that is 6. 22 divided by 6 is going to give us a non-integer value. Now, if k is a divisor of both m and n, then k is a divisor of m plus n and m minus n, or n minus m. For example, if m is equal to 21, n is equal to 36 and k is equal to 3, then 21 divided by 3 is going to give us an integer. Similarly, 36 divided by 3 is also going to give us an integer value. 21 plus 36 divided by 3 will also give us an integer, and 36 minus 21 divided by 3 is going to give us an integer. Lastly, if k is a divisor of n, but k is not a divisor of m, then k is not a divisor of m plus n and m minus n, or n minus m. For example, if m is equal to 21, n is equal to 8, and k is equal to 2, then 21 plus 8, which is 29, divided by k, that is 2, is not going to be an integer, as 2 cannot be taken out as a factor from 21 plus 8. We will now discuss remainders, which is a very important topic of GRE Quant. Now, 27 divided by 9 gives us a remainder 0. 11 divided by 4 gives us a remainder 3, which can be expressed as 2 or 3, or 2 with 3 in round brackets. This implies that 87 divided by 10 is equal to 8 with remainder 7. 22 divided by 5 gives us 4 with remainder 2. 50 divided by 5 is equal to 10 with remainder 0. Now, the terminology of this expression goes this way. 11 is the dividend, 4 is the divisor, 2 is the quotient, and 3 is the remainder. Now, if we have a question which says that x is a positive integer, when x is divided by 9, the remainder is 2. What are the possible values of x? Now, x can be 2, it can be 11, it can be 20, it can be 29, it can be 38, etc., etc. Because if 2 is divided by 0, it is going to give us 2 as remainder. Similarly, if 11 is divided by 9, it is going to give us a remainder 2. Now, kindly note that 9 multiplied by 0 gives us 0. And that is why if 2 is divided by 0, it is going to give us 2 as a remainder. We have another question on remainders, and this is exactly the same question that we have already discussed in the previous slide. The purpose of this question is to fully understand the concept of remainders, because it is going to be very helpful for your GRE 1 test. This question says that n and d are positive integers, and when n is divided by d, the remainder is r. What are some of the possible values of n? Now let us suppose that r is equal to 5 and d is equal to 7. Then n could be r, right? N could be r plus 7, which is 12. N could be r plus 2 times 7, which is 14, plus 5, which gives us 19. It can be r plus 3 times d, which is 21 plus 5 is equal to 26, and so on. Now, the basic thing is to remember that the multiple of the divisor plus the remainder is going to give us n. And this is the concept behind remainders. You got it? In the final slide, we are going to be discussing about rebuilding the dividend. Now, if we have 11 divided by 4, it is going to give us a quotient 2 with remainder 3. This implies that if we multiply the divisor with quotient and add it with the remainder, that is 3, we are going to get the dividend. If we rebuild the dividend where n divided by d is equal to quotient with remainder r, we get the dividend by multiplying the divisor with its quotient and adding it with its remainder. Now kindly note that if n divided by d is equal to quotient with remainder, then q into d plus r is going to give us n, that is the dividend. The possible values of n could be r, r plus d, r plus 2d, r plus 3d, and so on. Now the remainder is always going to be less than the dividend and greater than or equal to 0. That is, the remainder r is going to be between d and 0 or equal to 0. For example, if n is divided by 7, then the remainder is going to be equal to 0 or less than 7. Now if r is equal to 0, then the dividend, that is n, is divisible by d. If r is equal to 0, then d is hiding in the prime factorization of n. That is, the divisor is hiding in the prime factorization of the dividend. If r is not equal to 0, then n, which is the dividend, is not divisible by d, that is the divisor. If r is not equal to 0, then d is not hiding in the prime factorization of n. And with this, we come to the end of the video tutorial. I know it was a bit taxing, but with practice and understanding, you are going to become experts. In this week I will also be posting a video on questions related to divisibility and remainders. Best of luck to you and thank you very much. Goodbye.